Right, to verify this identity, I'm going to start with the left-hand side, and I'm going to multiply by the conjugate of the denominator. Because on the right-hand side, what I want to get to has a secant and a tangent, and the only way I'm going to get to that is if I have something squared. So I'm thinking about getting to those Pythagorean theorem identities. So in the numerator, I have I'm just distributing now. So distributing the cosine times 1 and cosine times sine. And in the denominator, I have, these are actually, if I distribute that, I actually get the difference of two squares. So I can do that a little quicker by doing this. And now in the denominator, when I multiply 1 minus sine by its conjugate, I get 1 minus sine squared, which I love because then I can apply that Pythagorean theorem and replace that with a cosine. That's going to help me get to that secant in the numerator. And then the numerator doesn't change. And now you'll notice I have cosine in all my terms. So I can take a cosine out of every term. In fact, before I do that, I'm going to decompose these fractions and split it up into cosine theta over cosine squared plus cosine theta times sine theta over cosine squared. And then I can take a cosine out here and one of those, and here and one of those, which leaves me with 1 over cosine theta, that's going to give me my secant, and sine over cosine, which is going to give me my tangent. So that equals secant of theta plus tan of theta, which is the right-hand side.